Hello, everyone. Hello. Okay, so let's start with today's sessions. Okay, so I know you guys might be a bit tired lah, because there are some of you actually join all three sessions. All right, you might join the biology early in the morning, then followed by the physics sessions. So I think I can feel that. Okay, I know that you might be a bit tired. All right. So thank you so much for sparing your time to actually having a 2 hours with me. All right. So I'll try my level best to ensure that you will learn something throughout these 2 hour sessions. Okay. So before I start, just a very quick questions, just to get to know more about you guys. All right. All right, guys. I want to know the populations and the demographics of the attendance today. Yeah. So if you are currently my Zoom class students, probably you can type number 1 in the chat box. So if let's say you are my students in the e-learning program, so you join the pre-recorded e-learning program, probably you type number 2 for me. All right. So if you never joined any of my class before, this is your first lesson with me, and maybe you can type number 3. Okay. So let me have a look first. Okay, all right, good. Okay, quite a lot of new students today. Okay, very good. Okay, guys, one more thing. Okay, so I want to tell you the house rule. Okay, wow, some people might feel a bit shocked. Wow, how come got house rule one? Biology don't have house rule. Physics don't have house rule. How come chemistry have house rule one? My rule very simple. Okay, so since you spare your time to attend this class, all right, I know you might be a bit tired. So if you want to drink some water, you want to take some food, feel free to do so, no problem. Okay, make yourself comfortable. But I only need 2 things from you. Number 1, stay focused. Okay, try your level best to stay focused for the next probably 2 hours. Number 2, anything you're not sure, please ask question. Don't be shy. Yeah, don't be shy, because we have the chance to meet online today. So please take this opportunity, to interact with me as much as possible. And don't feel bad. Don't feel like, okay, I might ask a very simple, lousy, stupid question. Don't have that kind of thoughts. Yeah. So for me, there's no stupid question one. No matter how easy the question, so you can ask. Okay. All right. And one more thing. So if you want to ask a question, I prefer you all ask the question in a public space. Okay. For my students, you all know that I don't like students to DM me or send private message, because for me, very simple. There's no secret between you and me. I don't think we need any secret talk. So when you send the message, you send the question in the public, everyone can read the questions and everyone can learn from there. Because some people, when they send the private message, they might have an idea. They say, the question I asked might be too, how say, too simple already. So I feel so shy. I feel embarrassed to ask such an easy question. Please don't ever think like that. Okay. So if you want to ask me any question, send the question in the public space. Okay. So without further ado, let's start with today's session. So I want to manage your expectation first. So today's session is approximate 2 hours. Okay. So our main focus is to get you prepared for your midterm exam. Okay, so I want to manage your expectation. What do I mean? If you are a person coming into these sessions, you know nothing about chemistry, or you are extremely weak in chemistry, don't have a wrong expectation. After listen to Mr. Martin talk shit for 2 hours, all in sudden you will understand everything. No, it's impossible. Yeah, it's impossible. You will learn everything in these 2 hours. Okay. But if you really pay attention, I can guarantee and assure you, you will definitely learn something. Okay, you will definitely learn something. Okay, because I don't want to waste your time. I feel very thankful that because you spare, your time to be here. All right. So that's why I'll try my level best to make sure that I give some value to you and you learn something throughout this session. Okay. All right. So let's start with these sessions. Okay. So I need to share my screen now. Okay. I need to share my screen. Okay. All right, guys. Just a quick one. Okay, can you see my screen? And can you see what is appear on the screen now? Okay, good. Thank you very much. Okay, so guys, what we're gonna do today? Our target for today is that we're gonna do a very quick revisions for your chapter 2 and chapter 3. But normally for your midterm exam, it really depends on your school. It depends on your school. Some school will have the midterm exam somewhere in the second week of July, some in the third week or fourth week. Some school even have the midterm exam in the first week of August. So depends on when they having the midterm exam and also the progress of your school. Okay, some of the school they will ask, the midterm exam will cover chapter 2, sorry, chapter 1, but chapter 1 is just introduction. Okay, chapter 1 is just introduction. Some of the school will cover chapter 1 all the way to chapter 4, but some school might go from chapter 1 to chapter 5 as well. Very unlikely, almost impossible that midterm exam will cover until chapter 6. Almost impossible. Yeah, so it's either chapter 1 to chapter 4 or chapter 1 to chapter 5. Okay, but like what I say, today we have some time constraint, so I won't be able to cover chapter 1 to chapter 5 all with you all. All right, but there's one thing. If you want to learn more about chapter 3, chapter 4, chapter 5, I'm not sure you guys know or not. Some of you probably know, I do have a YouTube channel. So in my YouTube channel, I have all the videos for chapter 3, chapter 4, and chapter 5, which you all can watch. Right? For example, chapter 3, there are total 5 videos. Chapter 4, probably 6 or 7 videos. It will really help you to understand the whole thing much better. Okay, right. So today, we will try our level best to cover chapter 2 and chapter 3. Yeah? So we are doing revision. So I will go a bit faster. Revision basically focus on 2 things. Number 1, important concepts. I will highlight the important concepts. Number 2, common mistakes of students and answering techniques. A lot of students say, sir, I think I know the concept. I somehow understand, but I don't get the marks I deserve. Sometimes I write the answer, I think it's correct already, but I don't get any marks or I don't get full marks. So what is missing? So that's what I'm going to tell you today. Okay, right. So let's start with today's session. So we're going to start our revision with something called matter. Okay, matter. So what is matter? So chapter 2 is quite easy because most of the thing in chapter 2 you learn in your PT3. Most of the thing in chapter 2 you learn in PT3 already. So it's not very hard. So we just go through quickly. Matter is referred to any substances or any substance that has mass and occupied space. So as long as this substance, it has certain masses and also occupy a space is called matter. Example, house. House has mass and house occupy a certain space. So house is a matter. Even something you don't see in this room is also matter. I'm not talking about ghosts. I'm talking about air. We can't see air though. We can't see the air, but we know air existed. So air has mass. Yes, it's super duper light, but air still has mass. Air occupied the space around us. So air also a matter. Second one, all the matter is made by something tiny and discrete. Okay, they make by tiny and discrete particle. They make by something even smaller. Example, okay, house is made of what, everyone? Bricks. Can brick made by something smaller? Yes, bricks can make by stone. Can stone make by something smaller? Yes, sand. Can sand make by something even smaller? Yes, maybe called silicon. Do you need to memorize the silicon? No need. Okay, I just want you to know everything is made of something even smaller. Even you and me, like I am a human. I am made of what? I am made of cell. Yeah, all of us, we are made of cell, something smaller. This something smaller is called particle. Yeah, we call it particle. So in chemistry, when they say particle, these 3 words must popping out in your mind. Atoms, molecules, and ion. Guys, is this easy? It's very easy. But believe it or not, a lot of students until Form 5 still cannot differentiate atoms, molecule, and ion. They still don't know atom, molecule, ion, what are the differences. So I teach you a simple one. Atom is somebody who come alone. So if you are alone, you don't have any friend, you are atom. Look at this. Okay, look at here. Okay, this one, you see the black color one? So these black color things don't have any friends. So these black color things is called atom. So anything come alone is called atom. All right, next one. Okay, so what is molecule? Non-metal group. When I say group means what? Can you form a group? One person? Cannot, all right? If you want to form a group, you must have more than one person, is it? You must have more than one person. So if you have non-metal and non-metal, they befriend together. Non-metal combine together. They are molecules. Example, look at the screen, please. You see this one, okay? Let's assume this black color things is a non-metal. Carbon, just assume it's carbon, no need to memorize. This blue color, let's assume is a non-metal, nitrogen. Non-metal, non-metal combined, this whole thing is called molecule, okay? Anything made by non-metal, non-metal combines together is called molecule. Last one, ion. What is ion? Somebody who has charge. So if you have charge, you are ion. Okay, some student will say, sir, I know one is called cation, one is called anion. My school teacher, my tuition teacher told me one is positive, one is negative, but sometimes I will confuse. So if you were confused, I teach you a simple thing. Just look at the word ion, okay, and look at the letter in front. Cation, this letter looks like what? T. T looks like positive. Anion right in front here, the N stand for what, everyone? Negative. Yeah. So anion is negative ion, cation is positive ion. That is very simple. Okay. So anything got charged, they are ion. But sometimes in exam, they are very, very bad. They're so bad, they try to put some trap. Okay, what do we mean by put some trap? For example, everyone put your eyes on here. NaCl. Now you tell me on the screen here, do you see any charge? Yes or no? Let me know in the chat box. Do you see any charges on the screen here? No. If you see the charge, something wrong with you. Something wrong with your eyes. There's no charge on the screen here. So this fella no charge, but actually this fella is ion. This fella is ion. Why? No charge, sir. No charge. Sometimes they are very bad. They hide the charge from us. The Na is Na plus, the Cl is Cl minus. Then it comes to a question. Student will ask, sir, how I know they hide the charge from us or there is no charge at all? So that's why for ion, you have two ways to identify. First one, ion is somebody who has charge or somebody made of metal and non-metal. So if you have metal and non-metal combined together, although you don't see any charges, they are ion. Example, okay, sodium is a metal, chlorine is a non-metal. So metal and non-metal, so they are ion. Okay, some student will ask me, Mr. Martin, do we need to memorize who is metal and who is non-metal in the examination? The answer is no need. The answer, no need. Then how you know the substance is metal or non-metal? Actually, you don't need to purposely memorize. When you keep doing more and more questions, when you go through the entire Form 4 and entire Form 5, this thing just automatically go into your mind. But if you really want to know, I will teach you two simple methods. I teach you two simple methods. How to know the substance is metal or non-metal. Metal, normally the name ended with the word ium one. For example, magnesium, sodium, aluminium. Okay, so normally the name got ium, they are metal. Does it mean that all the metal, the name must be ium? No lah. Okay, example, iron. Iron, the name don't have ium, they also metal. Silver, the name also don't have ium, but they are also metal. So these rules is okay, but not apply to everything. So how are we going to know who is metal and non-metal without memorizing? In SPM, do you all know that you are given periodic table? Let me know in the chat box. Do you know that periodic table is given in SPM? Do you know that? Okay, some of you know, some of you don't know. Okay, so periodic table is given. So some school, they ask you to memorize periodic table. That is nonsense. That is nonsense. I always tell my student, if you really want to memorize, don't waste too much of your memory in chemistry. Okay, chemistry, do you need to memorize? Yes, but not memorize every single thing. Okay? Many people, they study chemistry in the way they study sejarah. They memorize every single things. Okay? So if you are good in memorizing, you might be very good with sejarah or even biology. Okay, let me share with you a simple. I'm not sure whether I tell this or not. Maybe I told this in my class before. Okay, one of my friend, my good friend, he is the top scorer for biology in SPM. Year 2003. Okay, so he got 98 marks in SPM. 98 marks in SPM for biology. Guys, 98 marks, good or bad? In SPM, good or bad? Okay, it's not good, right? It should be damn good lah. It should be damn good. It should be fantastic. Very good. But you know what he told me? He said, hey, Martin, actually, I don't understand biology 1. I say, bro, are you kidding? You don't understand? Oh, there's a student asked, SPM, can you know the marks? Normally you don't know the marks. Why my friend know the marks? Because my friend is the top performer for sejarah in Selangor that time. So for top performer, actually you can ask about your mark line. Top performer, okay? Like for example, let's say my chemistry is top in Selangor. I can go to check my mark. Other than that, you won't know your mark line. Okay? So he got 98. He said, wow, sir. Sorry, he said, Martin, I don't understand one. So I'm not angry, you know. I feel like, how come was you insulting me, bro? You don't understand bio, but you get 98 marks. But it makes sense, my friend, not only the top students for biology, he also top students in sejarah. What you see in common, everyone? What you guys can see in common? Anything in common? Memorizing. He's damn good in memorizing. Okay, he's damn good in memorizing. He can half one. And guess what is his job today? He is a lawyer. Does it make sense now? He's a lawyer. He's a lawyer now. So he's damn good in memorizing now. Okay, so even he don't freaking understand about the biology, he still can score very well. But that's for bio. Bio, if you really know how to memorize and you know how to apply, you're going to get a very good marks, but not for chemistry and physics. Okay, in chemistry, you need to really understand the concept. So cannot memorize everything. So that's why I don't like when people ask, memorize periodic table. Nonsense. Don't do that. Okay, right. So let's go on. So now we know already what is atom, molecule, is ion. Another one more thing you need to know is this. A lot of students always mess up these three things as well. Elements, compound, and mixture. What is element, compound, and mixture? Element is anything that made of one type of atom only. The keyword is here, one type. When you only have one type of atom, you are element. Mark down my word, one type, not one atom. Okay, what do you mean a one type? Example, carbon. How many type? One, because you only got C, nothing else. So it's one type, so you are element. Zinc, only Zn, nothing else, one type, so it's element. O2, here got people start to confuse already. Sir, O2 got two leh. Both of them are O. I am O, you are O. Are we same species? Yes, you are O, I am O. I don't care you have 40 O or 70 O. All of us, we are O. One type of atom only. So we are element. S8. Although you are 8 sulfur, but all of them same species, same type of atom. So they are element. Because many students always mess up element and atom. They are two different concepts. Okay, allow me to ask a simple question here. Let's say, allow me to ask you two questions here. The first question, zinc. So my first question to you, is zinc an atom? Yes or no? Is zinc an atom? Yes or no? Yes, right? What is atom? Somebody who is alone, don't have friend. Zinc don't have friend, so it's atom. Second question, is zinc an element? Yes or no? Yes, right? You only got Zn, nothing else. You only have one species, so it is element. So no conflict one. You can be atom and element at the same time. No conflict. A lot of students mess up atom and element a lot. Okay, so if let's say you are one of the students that previously always confused about atoms and element, probably you type number 6 in the chat box. At least I know that. Yeah, all right. But if you're okay, then no need lah. Okay, so if you always confuse atoms and element, type number 6 in the chat box. At least I'm aware of it. Okay, next one more question here. Let's say this fella is called O3. So my first question, O3. Okay, is O3 an atom? Yes or no? O3 atom? Yes or no? No, because you are not alone. You have 3 oxygen be friend together. You are not alone. Next one, it's O3 an element? Yes or no? Yes. You only have O, nothing else, right? You only have one type of atom, one species. So you are element. Simple as that. So this is something very easy, but you all have to be very, very careful. Yeah. So this is element. Okay, what is compound? Compound is anything made of 2 or more types of atom. Simple words, many species. So if you have more than one species, I call it as compound. Example, okay, CO2 is a compound. Why? You have C and O, 2 types of substances, 2 types of atom. So you are compound. This fella, it's called ethanol. You don't need to know the name. You have how many types of substance? You got C, you got H, you got O. You got 3 different types of substances inside. So you are compound. So NaCl, Na is one type, Cl is one type. So you are compound. So when you have more than one species, you are compound. So this is very easy, but you all have to be careful. Okay. So last one, mixture. Okay, some students cannot differentiate mixture and compound. What is mixture? They only mix. They only mix. They didn't combine to form something new. They only mix, and then they can be separated easily. Okay, what do I mean? Example, if I got green bean and red bean put together, are they mixture or compound? Mixture, because I can separate green bean and red bean, kacang merah, kacang hijau, okay, easily, I can do it. But today, if I have carbon and oxygen combined like this, carbon and oxygen combined like this, let me know in the chat box, do you think this is a mixture? Yes or no? Carbon and oxygen combined together, do you think it's a mixture? No, because it's very hard for me to separate carbon and oxygen. Can I separate? Can, but very, very hard. I need to go through some special chemical process that only can. But mixture, you can separate easily without any chemical process. So hopefully every one of you here know the differences between these 6 differences. These 6 things are: number 1, atoms; number 2, molecules; number 3, ion; number 4, element; number 5, compound; number 6, mixture. Okay, type number 6 if you understand what am I talking about. Okay, so make sure you know these 6 terms are very important: atoms, molecule, ion. Okay, elements, compound, mixture. They're very easy, but you have to be careful. Okay, next part. Okay, this thing you have seen, this part you have seen in your PT3, right? PT3 you already learned already. What is solid, what is liquid, what is gas. So I don't want to waste too much time on here. I only want to tell you a few things. When you come to SPM, the way they mark the paper is a bit stricter compared to your what we call that PT3 lah. Okay, if any one of you attended Mr. Core biology sessions early in the morning, so he got mentioned that now SPM is trying to, now the Ketua Pemeriksa is giving instructions to the Pemeriksa to mark the paper in a proper way. Proper way means what? Mark strictly. If anyone attended Mr. Core session, you should heard this, okay? During MCO, that was the start of KSSM. By right, KSSM syllabus is harder compared to KBSM. And student cannot go to school. But when the result came out, the result was damn good. Never in my life, I have seen so many students get straight A1. Never in my life. Crazy one. I get the message, guys, imagine this, students will text me normally when they get the result. The first 40 messages I received, the first 40 messages I received, 27 students get straight A. Something wrong. Seriously, something wrong. It cannot be that high one. Okay, why? They mark the paper very, very lenient, very easily. So it's not good. So the student feel good. Yes, I am a straight A student. And these straight A students, when they go to A level, fail the first exam. Straight A student fail the first exam. Why? This fellow shouldn't be qualified to get straight A1. Just because the marks is, the way of marking. I can't comment much, the way of marking. So these students feel good and somehow get straight A. Yeah, but the quality is not there. But this year, you can really see the latest batch. The latest batch who get a result recently. This one is okay. You can really see that. Okay, those people who get straight A, those people who get A, A minus, A plus, they are really qualified. They are really qualified to do that. Yeah. Okay, now, guys, I want to tell you there's some difference between SPM and also what we call that the PT3. You see, in PT3, if they ask you to draw solid, you draw like this, full marks. Okay, in PT3, if you draw like this, full mark. In SPM, you draw this diagram, 0, nothing. Okay, why? Okay, so because in SPM, there is a requirement. When you draw solid, you need to draw minimum 3 times 3. So minimum 3 times 3 means what? Minimum 3 over here and 3 over here. So which means I need to see minimum 9 circle. Minimum. So can draw more than 9 or not? Of course can. Okay, another one, guys. I got one student who draw like this. Okay. Guess how many marks this student can get? Full mark is 1. How many marks this student can get? 0. Why? Why? Why he didn't get full marks? 9. 9 circle. Why? Because this box is not full. Solid should, okay, Nigel, very good, has space. Solid shouldn't has any space. They should be fully crammed out, fully occupied. No, you don't want any space at all when you come to solid. So you see, when you come to SPM, they are more particular, they are more stricter. Okay, so you have to be careful. Something that can get you full marks in PT3 might not works in SPM. Next one, how you draw liquid in PT3? A few things, a few things, a few things. Am I right? This is how you draw liquid in PT3. If you draw like this in SPM, 0 again. Okay, why? So in SPM, when you want to draw liquid, you need to draw like this. You need to draw a group, we call a gang. This is one gang. This is one gang. So you need to draw 2 or 3 gangs. Every gang must be 4 to 6 atoms. Can it be more than 6? Okay, maximum draw until 10. Maximum, like this gang got total 10. Another gang got total 10. It's okay already. And don't draw so nicely. Don't draw like this. Oh, Mr. Martin say one gang got 6 people. Don't draw like this. Why? Too beautiful already. Too orderly. Cannot. Liquid don't want to be so organized. Okay. In BM, kita tak nak tersusun. So in liquid, in cecair, we don't want the whole thing to be so organized, so tersusun. We don't want. So you draw like this. Okay. A few like this. A few like this. So this is a liquid. So this is 2 gang. 2 to 3 gangs is enough. If you only draw 1 gang, can or cannot? Cannot. So can you see? These things seems very easy, right? Solid, liquid, gas, you thought it should be very easy, but it's not. That's why a lot of people, even a lot of students, when they answer SPM exam, even the question only asks them to draw solid, liquid, and gas, don't get marked at all, just because they don't know about these small details. Okay, last one, gas. Okay, how you draw gas in PT3? Okay, you learn about gas, I think probably in Form 1. Form 1 or Form 2, I can't remember. Okay, so gas, you draw like this, right? PT3, simplest one. Okay, simplest one. Okay, gas, you draw like this. Now, a lot of people thought gas must be only 1 atom, 1 atom, 1 atom. Allow me to ask a question. If today got 2 atoms, can I draw a gas like this? Yes or no? Yes or no? Can I draw 2 atoms for gas? Okay, yes. Okay. Can I draw 3 atoms for gas? Yes. Can I draw 4 atoms for gas? Okay, some students started to say no already. All right. Okay, some students say no. Can I draw 5 atoms for gas? So some students will say no also. All right, the answer is yes. Okay, so actually even 5 atoms also can be gas. You see, why? You see, now a lot of you, mind-blowing, right? Something like, okay, why it can be 4 atoms one? Okay, let me show you a simple gas. No need to memorize. One of the gas is called ammonia. Ammonia is a gas that you will smell when you go to toilet. After you pee, after you pass water, you don't flush. If you don't flush, after a while, you get a very bad smell, the choking smell. That is ammonia. Ammonia, the formula is NH3. Okay, guys, how many atoms in ammonia? 1 N, 1 nitrogen, 3 hydrogen, 3 hydrogen, 4. So ammonia is a gas. How many atoms you have? 4. So 4 atoms also can be gas one. What about 5? 5 also can be gas. Example, CH4. CH4 is methane. No need to memorize. Methane, all of us can produce when you fart. Okay, kentut, when you fart. Okay, methane. So methane is a gas. When you kentut, it's not a liquid, right? It's not a solid, right? You kentut is a gas, CH4. Do you need to memorize? No need. 1 carbon, 4 hydrogen. How many? 5 atoms. So can be 5 atom one. So gas, not necessary 1 atom. 2 atom, 3 atom, 4 atom, 5 atom also can. Then some students start to confuse already. Some students say, sir, just now you say 4 to 6 atom together is a liquid. Then to get now, if I got more than 4, can it still be gas? Yes. Then how you differentiate a gas and a liquid? Look at here. If you are a guest, let's say 4 people and 4 people. If you are a guest, these 4 people and 4 people, they are far apart, you see, very far apart like this. If you are liquid, these 4 people and these 4 people are closer together. Let me know in the chat box. Are you okay? Do you understand now? So liquid, the gang are together, close together one. The gang got how many? 4 to 6. Gas, the gang are far apart. So when you want to draw gas, make sure you draw very far apart lah. Like one here, one here. This one you want to draw 5 also can. This one you don't want to draw 5 also can. 5 and 5, but they are far apart. They are gas. Okay, so as simple as that. All right, so no problem. Okay, so Joshua, of course you can say that you only draw 1 and 2 molecules for gas to be safe. No problem, of course you can do that, Joshua. Okay, just that you need to know that, okay, if they give you a picture got 5 atoms, that you need to know that it also can be a gas. Of course, if you are given a choice when you draw, just draw 1 and 2 lah. That's easy for you lah. That is the case when you draw lah. Okay, all right, good. So finish, huh? So can you see everyone? Solid, liquid, and gas, something that looks so easy actually can be so particular. So these are some things, these are some secret that a lot of students, they never know. Next one. Okay, you all must know how to change the state from one to other, solid to liquid, liquid to gas. All these things everyone must know. I don't want to waste too much time on this. So I want to emphasize on this one only. Solid change to gas is called sublimation. Gas converted to solid directly is called deposition. Okay, so deposition is being asked more frequently in KSSM. In the O syllabus, in the KBSM, they seldom ask about deposition. They always ask solid to gas directly, which is sublimation. But they started to ask more and more deposition starting from KSSM syllabus. So everyone must know, gas convert to solid directly without passing the liquid. That is called deposition. Okay? So Ashru asks, can I write reverse sublimation? You can write, but you won't get any mark. Okay, I won't stop you from writing, but you won't get any marks. Okay, cannot write reverse sublimation, cannot, not acceptable. Okay, so now you must know in SPM there are total these 3 substances. You need to know them. These are the substances who can undergo sublimation, which means these 3 substances, when you heat them, they are not going to melt. They won't melt. They won't become liquid. They will change from solid directly become gas. The first one is called iodine. The second one called solid carbon dioxide. Solid carbon dioxide is the dry ice. Like for example, sometimes when you see some singer on the stage, like K-pop singer, when you see on the stage, they have some smoke, the white color smoke. That is not the smoke actually, that is dry ice. They use the dry ice to create those stage effect that looks very nice. Okay, the last one is called ammonium chloride. So these 3, do you need to memorize them? If you can, you should. But if you cannot, no problem. Just read through will do. Because normally, these things were asked in objective question. They were asked in objective question. So at least you have some answer to choose. Okay, my last question to ask you before we do some good quality question, because today we want to do this. We learn something, we revise something, and we do exercise. We revise something, we do exercise. Okay, so that you know how to apply whatever thing you learn. Okay, so guys, allow me to ask you a simple question. Do you know how to differentiate boiling and evaporation? Boiling change liquid to gas. Evaporation also change liquid to gas. If you know the differences between boiling and evaporation, you type number 1. If you don't know or a bit confused, what is the differences between boiling and evaporation, please type number 2 for me. Okay, if you know the differences between boiling and evaporation, type number 1 in the chat box. If you don't know the boiling and evaporation, what are the differences, you type number 2. So let me see. Okay, I can see from the chat box, majority of students can understand, but still have some students maybe not so sure. No problem. I'm here to help you. So what is the difference between boiling and evaporation? 2 differences. Number 1, boiling only occur at boiling point. For example, if you want to boil a water only boil at 100 degrees Celsius. Water do not boil at other temperature. Okay, evaporation evaporation occur at any temperature. Any temperature also got evaporation. Example, I take a cup of water, example here. Okay, I take a water bottle here. Maybe you cannot see. Yeah, this water bottle. This water got 500 ml. I put the 500 ml water in an air conditioner room. Aircon room, the room with aircon, very cool. So initially got 500 ml. After 1 week, 500 ml become 200 ml. Where is another 300 ml? They become gas already. So what is the process? Evaporation. Why? Because the liquid become gas at aircon room, not heating. Like you don't need to heat. You don't need to heat until the boiling point, 100 degrees Celsius. So this is called evaporation. Number two, second difference. Boiling happen in the entire liquid. When you boil, the whole liquid will boil. Okay, for example, when you heat the water like this, where you will see the bubble, you will see the bubble in the entire bottle. You don't see the bubble only on top, only at the bottom. You see the bubble whole thing. Okay, so boiling happen throughout the entire liquid. Evaporation only happen on the surface. So this is the water. So the surface will evaporate first. Okay, so let me know in the chat box. Okay, so for those who answer number 2 just now, okay, do you have a better idea now? What is the differences between boiling and evaporation? Are you okay? Okay, fantastic. Very, very good. Okay, so you see, at least you learn something, isn't it? All right, at least you learn something. Okay, Shimping. I hope I pronounced your name correctly. Shimping. During boiling, does evaporation occur? Yes. Okay, when you heat the water, evaporation also happen. Okay, evaporation happen anytime. Anytime, any temperature, evaporation always happen. Yeah. All right. Now finish. Okay, so we're done with this. So now let's do some question. Okay, guys. Here I want to talk a little bit off topics. A lot of students, the way they study is what? They study. They just simply study. Study as in they go and read. They read a lot. A lot of students, they read, but they don't understand how to apply the concepts. Okay. So I would suggest this because a lot of maybe some teachers, no matter school teachers, seminar speakers, or even tuition teacher will tell you, you only start to do more question in Form 5. I disagree. Okay, I disagree. I think you should start doing question as early as possible in Form 4 because you want to get used to SPM format question. So when you want to do question, always do good quality question. Good quality question. I'll recommend you all do some past year paper as well as some trial exam paper, which you can get easily online. Yeah, you can get all these things easily online or some Telegram study group. You can get it easily because only when you do the question, you will know what is your problem. Because some students, they feel good about themselves. Remember the straight A story I said just now? These students so damn happy. I am a straight A student. First exam in A level, fail. Yeah, because he or she feel good. I'm damn good lah. I'm straight A lah. I'm damn good lah. But maybe he or she is not that good. So you need to do this question because when you do this question, you know where you start, what kind of question you can do, what kind of question you cannot do. So when you know which part you got stuck, then the next thing is that you must improve on that. You must solve the problem. There's some students like this one. Some students, when they do the question, let's say they do the mole calculation, they always stuck at mole calculation. So what is the solution for them? Never do mole calculation. Don't want to do mole already. They skip. They go to do other thing. No. All right. So if you know you're stuck in mole calculation, you have to think a way to solve it. Example, ask your friend who understand the mole calculation. Number 2, ask your school teacher, ask your tuition teacher, ask me also can. At least you need to find a way to solve it. Not to say, oh, I know my sejarah sucks. Okay, so I don't do anything about it. That's it. Okay, that's it. So do you think that you don't do anything on it and all in a sudden, okay, let's say after 3 weeks, all in a sudden when you woke up in the morning, all in a sudden you understand already? No way. If you don't want to do anything about it, it won't change. It won't change. Yeah, so you need to do it. Okay, let's look at it. So the first one, can everyone try to do this together with me? So what process occurs when iodine crystals are heated at room temperature and pressure? Come on, let's try this. When you heat iodine crystal, what happened? A, B, C, or D? The answer is D. Why? When you see the word crystal, crystal means what, everyone? Solid, solid. When you heat the iodine solid, what will happen? Iodine do not melt. Iodine is one of the 3 special substances I showed you just now, which undergoes sublimation. So iodine, when you heat it, the solid change to gas directly without going through the liquid. That's it. Next one. Which of the following substance is an element? Okay, what is element? We learned just now. One species. Only got one species. What it is? The answer is very good. Okay, good job. Okay, well done, well done. Okay, I can see. Okay, I like when you all actively participate in the class. I'm very happy. Nigel, okay, Shrimping, Deepti, I hope I pronounced your name correctly. I'm not really good with pronunciation. Monica, Putri, very good. The answer is C. Why? Okay, why the air is not element? Air inside got many things mixed together, right? Air got carbon dioxide lah, nitrogen lah, oxygen lah, many things mixed together. So air is a mixture. Air is a mixture. So it's not element. Steam. Steam is H2O. So steam got H and O, 2 species. So 2 species, you are compound. You are not element. Element, 1 species only. Carbon, C. You are only 1 species. So you are element. Yeah. So this question not hard, but it's good. Yeah. Come, let's try one more. This is SPM 2017. All right. Okay. Huzaiman asked why air is not a compound. Why air is not a compound? Good question, Huzaiman. In air, you have nitrogen, oxygen, carbon dioxide, steam, and many gases. Can you separate nitrogen gas, oxygen gas, carbon dioxide gas? Can. Okay, you can pass through a special tower called fractional distillation. You can pass through this fractionation distillation tower. No need to memorize. When the air go in, they will split the gases. So the gas can be split easily. That's why it is a mixture. Compound, very hard to split. Uzaiman, did I answer your question? Fantastic. Okay, very good. Okay, so I like that. Huh? Anything not sure, you ask. Yeah, you ask, you get an answer. And sometimes when you ask, your friend who attend the class, who attend the session also learn something from there. Yeah, that's why I want you all to send the message to the public space. Everyone learn together. Okay, next one. This is the real SPM past year question in the year of 2017. Hey guys, you're so fast. I haven't asked you all type the answer already. So fast. Okay, so a lot of you type answer A. Is it A? Yes. Okay, why? Okay, this question, if you look at the name, the name is not very useful when you want to determine the particle. Okay, remember what is particle? There are 3 particles out there. Particle means something smaller inside the matter. So you have atom, you have molecule, you have ion. So atom must be alone, molecule must be non-metal group. Ion must be something got charge or something metal and non-metal. Something we learned, something we revised moment ago, right? So in this case, if they give us the name, the name is not very useful. We should convert the name to formula. Ammonia, the formula NH3. Okay. With this one, actually, you learn in chapter 3. Later, I'll tell you a little bit how to memorize. Neon is Ne. Nitrogen dioxide, nitrogen is N. Di is 2. Chemistry, di is 2. Oxide means oxygen. 2 oxygen, NO2. Hydrogen chloride, hydrogen is H. Chloride is Cl. So when you look at the formula, then it's easy. So they say ammonia is molecule. Yes or no? Yes. Why? What is molecule, everyone? Something made of non-metal and non-metal. Nitrogen, are you non-metal? Yes. Hydrogen, are you non-metal? Yes. Okay, come back to a question I didn't answer just now. I forgot to answer. How you know the substance is metal or non-metal without memorizing? In SPM, you will be given periodic table in your paper 1 and paper 2. Paper 3, they don't give you because you don't need a periodic table in paper 3. So in paper 1 and paper 2, they will give you a periodic table. So you look at the substance in periodic table. Everyone from group 1 to group 13, they are metal. Nigel is 13, not group number 3. Okay, group 14 all the way to group 18 is non-metal. So you just need to check. Let's say today I have a substance A, which is here, group number 2, metal. I have a substance W, which is here, group 17, non-metal. So you check which group, then you know already that substance is metal or non-metal. Yeah, that's everything you need to know. Okay, so nitrogen, if you go to check, nitrogen is here. Group 15 is the non-metal. Hydrogen don't have any group at all. Hydrogen is the one and only substance in the world that don't have any group. Because many people thought hydrogen is here in the periodic table. They thought hydrogen is group number 1. No, hydrogen don't have any group in the periodic table. Yeah, hydrogen no group 1. So common sense, common sense. So hydrogen is non-metal. Common sense, I don't think you say hydrogen is metal. Okay, so hydrogen is non-metal. Okay, so non-metal nitrogen and non-metal hydrogen combined together, it's molecule. That's it. Okay, I get a question in the chat box. Okay, this is a good question, and this is a common question a lot of students ask. HCl, this formula, why sometimes they call it hydrogen chloride? Why sometimes they call it hydrochloric acid? Okay, so this is very, very important. Okay, I hope I pronounced your name correctly, Miftahul. Miftahul. Are you in Form 4 or Form 5? Are you in Form 4 or Form 5? You're in Form 4 or Form 5? Form 5. Okay, so I'm quite sure that, okay, because when you ask about acid, I know already you're supposed to be in Form 5. Okay, I know that because in this group there are a lot of students who are Form 5 today, which is good. Okay, I'm very happy to see the effort. At least you make your time to attend some Form 4 revision. Fantastic effort. Okay, so now listen carefully. Form 4 students haven't learned about acid yet. Is in Form 4 chapter 6. Yeah, the hardest chapter in Form 4. Okay, so but a simple thing. How you know who is hydrogen chloride, who is hydrochloric acid? Very simple. You go to see what are the form. If this HCl is in a gas form, you call it as hydrogen chloride. If the HCl is in solution form, solution means what? The HCl dissolve in water. The HCl dissolve in water. So it is hydrochloric acid. So shrimping, very good answer, shrimping. Okay, a good gas. So when HCl do not dissolve in water, call it hydrogen chloride. If HCl dissolve in water, call it hydrochloric acid. Because if you are Form 5 student, you know that acid and alkali need water. Without water, the acid and alkali, they are dead. Okay, you need water to make acid and alkali come alive. Did I answer your question? Let me know in the chat box. Okay, very good. So let's move on. Okay, so one more. Okay, this question I don't want to do too easy already, too simple. Skip. Okay, next one. Okay, so the next thing I want to revise with you something called 3 lines method. Okay, 3 lines method is a special method that can help you to predict a substance to be in solid form, liquid form, or gas form at a specific temperature. They love it. They always love to ask this question, especially in your midterm. In your midterm, I'm very sure they will have one question like this. Okay, mostly in objective, they will ask at least one question. Okay, so simple. The question look like this. Let's say substance Z, the melting point. The melting point for substance Z is -17. The boiling point for substance Z, let's say 91. So they ask, what is the states of substance Z at 40 degrees Celsius? Okay, when they ask you the word state, it means solid, liquid, or gas. So your brain must be automatic connect to some keywords, everyone. When I say particle, proton, sorry, when I say particle, atom, molecule, ion. When I say states, solid, liquid, gas. So how to know this is solid, liquid, or gas? Okay, some of you might be very fast one. Some of you, you look at it, you know already it's liquid. I can see in the chat box, some of you very fast one, you know it's liquid. But some students are a bit weaker. Okay, that's why in this group we have different people with different learning capability. Some very fast and smart, some might be a bit slow and weaker. It's okay. Yeah, it's okay. Right? You can learn at your own pace. Don't compare with others. So if you are weak students, I teach you a simple method, which is called 3 lines method. How to use 3 line method? As the name tell you, 3 lines. Draw 3 lines. First line, horizontal. second and third line vertical. So this one is the first intersection. Can you see? Intersection. The first intersection here is melting point. Second intersection here is boiling point. So your melting point, how many? -17. Your boiling point, how many? 91 is given here. Okay, the first box here is solid. The second box here is liquid. The last box here is gas. So now you just ask yourself, what is the temperature that we wanted? We are looking for 40 degrees Celsius. Let's do mathematic number line. So where is 40? Mathematic. -17 and 91. 40 should be in the middle here. So in the middle here, who are you? Liquid. Okay, 40 is in between -17 and 91. So 40 is here, in between. So you are a liquid. Let me know if you think this method looks a bit easy for you, especially for those weak students. Maybe you can type number 4 in the chat box. Okay, so if you are a weak student, this method will help you a lot. But if you are very smart students, you not even need to do this. You look at the question, you know the answer immediately. Yeah, all right. Now let's look at one good quality question. Okay, this is a trial exam question for Kelantan 2022 trial exam paper. Soalan percubaan Kelantan, right, 2022. So they give you 4 substances, melting point and boiling point. They ask you, who is the gas at room temperature? So my first question to all of you guys, room temperature, it's how much? In BM, berapakah suhu bilik? Suhu bilik berapa? Okay, 24, 25, 27. Okay, around there. Good. Okay, 27. Okay, so listen carefully. In chemistry, not only chemistry, biology, and also physics. When I say room temperature, normally we refer to 25 degrees Celsius. Fixed already, 25 degrees Celsius. And don't think too much. Don't think too much. Some people say, sir, if the person live in Saudi Arabia, super hot, so the room should be hot, should be 40 degrees Celsius. Don't think so much. Sir, this person live at North Pole, super cold, the room very cold, so cannot be 25 degrees Celsius. Don't think too much. So in chemistry, they fix it. When I say room temperature, no matter which country you are, no matter your room got aircon or not, 25 degrees Celsius. Yeah, not 24, not 27. Yeah, 25. Okay, so now let's do it. They ask, who is gas? Okay, so let's try this. Okay, how to do who is gas? So okay, you all can try, maybe you can try. Let's see who is gas. So 25 degrees Celsius. Okay, let's say substance P, 3-line method. Melting 80, boiling 120, solid liquid gas. Room temperature 25. Where is 25? 25 lesser than 80. So here. So you are a solid. So when you do objective, guys, do in a smart way. When the answer is wrong, directly eliminate. What is eliminate, everyone? Throw the answer away. You see, when P is wrong, which means answer 1 is wrong. When answer 1 is wrong, so A and B confirm out. So you see, now even you want to tembak your answer, only 2 answers left, 50% already. The chances is much higher. Of course, if possible, don't tembak lah. But you can see that in objective, always throw the wrong answer first. Then you can increase the chances of winning. Yeah. So now you can see answer 3 and 4. Actually, answer C and D. Number 4 is there. So confirm number 4 is correct. So not even need to do number 4 already. Only do 2 or 3. So 2 or 3, let's look at it. Number 2, okay. Number 2, this is substance R. Okay, sorry, substance Q, sorry. Substance Q. So substance Q, melting point 50, boiling point 95. So room temperature 25 here, solid. So solid. So you don't want solid, you want gas. So Q is wrong. So when number 2 is wrong, 3 and 4, answer is donkey. Not very hard, right? So as long as you follow these rules and principle, it's actually very easy only. Quite easy, I would say. This question actually quite easy. Okay. But when you use the elimination method, it saves you a lot of time when you come to objective. And guys, you all have to be careful. When you come to objective, not to only say objective, when you do the questions, you all must try your level best to avoid careless mistake. Some students are very, very careless. If you think you are a careless student, maybe type number 1 in the chat box. If you think you are a careless student, type number 1 in the chat box. A lot, okay? Guys, I share with you a simple story, okay? I got one student who is a legend. When I say legend, normally when I say legend, it's not something good, right? It's not something good, huh? So these legendary students are, he's really another level one. He's really another level one. I teach these students back in year 2009. In 2009, I taught these students. I think he was in Form 4 that time. Okay, Form 4. Form 4 final exam. Because of careless mistake, this fella lose 24 marks. This fella lose 24 marks because of careless mistakes. What is the logic? If he don't lose, if he don't do careless mistakes, he's supposed to score A+. Okay, he's supposed to score A+. Just because of careless mistakes, I think he only get B or C. So many different grade. I think B lah. I think 4 grade different. 4 grade different. Yeah. So you have to be very careful. Okay. If you are a careless person, just admit it and be careful, because you might heard this SOP from a lot of seminar speaker and also teacher. Okay. They say, all right. This okay, Xinping, what careless? Okay, this fella careless. Number can write wrongly one. Decimal place can put wrong one. Super careless one. The eyes got problem this fella. Yeah, I joke lah. Yeah, I always tease this person. Hey, your eyes got problem, is it? How come decimal point also can put at the wrong place one? Okay, super careless lah. Okay, you won't be able to imagine like what kind of careless mistake he made lah. Super stupid mistakes one. Yeah, right. So guys, if you know you are a careless person, you have to be super careful when you do the question, because you heard this a lot of time. You heard, hey, when you do the paper, you must check your answer. I'm not against anyone. I'm not against anyone. All right. But for me, although it sounds a little bit harsh and offended, I will say it's bullshit. I will say it's bullshit. Okay. Why? If you are a careless person and you make the mistakes, when you check your answer, very unlikely you will able to spot the what is going wrong one. Really one. How many of you, when you check your answer, you really can check and you found out what is going wrong? God, very little. Less than 5%. Trust me. Less than 5% of students, when they check the answer, they were able to check what is their mistakes. Most of them, they won't. They just check for fun only. They check, oh, feel good. Oh, I got to check my answer. You won't be able to find out your own mistakes one most of the time. Seriously. Yeah. So if you are a careless person, don't waste your time to check lah. You have to start from the root, start from the beginning. When you do the question, do carefully. Do carefully. Yeah, that's it. Okay, come on. So the next one, everyone, can we try this question together? Quick one. Putrajaya 2022 trial exam paper. Who is a liquid at 100? Come, let's try. Who is a liquid, okay, at 100 degrees Celsius? Okay, very good. The answer is C. Fantastic. Okay. So since most of you get it correctly, I won't discuss. But if you don't know how to answer, let me know. Put an X. If you don't know how to answer, then I will teach. Yeah. Very simple one. You use this method, 3 lines method. Okay. All right. Mariza, don't know how to do. No problem. Okay, who is liquid? You see, Y cannot be W. Melting point, -157. Boiling point, -9. 100 is where? Mathematic. 100 is on the 100 is more than -9, right? So this is gas. So do you want gas? No, I'm looking for liquid. Look at X. -13 is the melting, 55. -13 and 55. So what is the temperature you want? 100. 100 more than 55 here. So this is solid, this is liquid, this is gas. So gas, I don't want. Next one, substance Y. So substance Y, if you look at it, okay, if you look at the substance Y over here, melting point 80, boiling point 196. Okay, so what is the temperature you want? 100. 100 is where? 100 in the middle of 80 and 196. Solid, liquid, gas. In the middle, liquid. Okay, Maritza, can you understand now? Okay, all right. So that's it. So you see, when you use the 3-line methods, you can get it easily. It's not hard, but you need to be very, very careful. Sometimes even the topics is very easy, but a lot of students still get it wrong because they don't write the keyword, careless mistake, this and that. So have to be very careful. Okay, the next one. This one will be something very important in your chapter 2. If you are Form 4 students, okay, because like what I say, there are a lot of Form 5 students in this group for today. If you are Form 4 students and you are sitting for your midterm exam, I'm very sure that there will be a question on this, heating or cooling curve. They might ask any place. They might ask in objective, they might ask in subjective, or even they might ask in essay. So you need to know your heating curve and cooling curve very, very well. So I'll spend about 10 minutes to do a quick revision with you guys. What is heating curve and what is cooling curve? So if any one of you struggle for heating curve and cooling curve previously, please take this opportunity to learn and ask if you still have any problem after I explain. Okay, heating and cooling curve, how they looks like. Heating and cooling curve, the shape is actually staircase. They look like staircase. In BM, bentuk tangga, bentuk tangga. So you have two types of staircase. You punya tangga can go up or go down. So you can see how to draw tangga, up, flat, and up. Okay, so or it can be down, flat, and down. So you have two shapes only. Tangga menaik atau tangga menurun. So you have two possibility. The staircase going up or staircase going down. All right. So how to know which one is heating curve, which one is cooling curve? Use common sense. Okay. Heating curve and cooling curve is what? Heating curve and cooling curve, you all can write down if you want. It's a graph. Heating and cooling curve is a graph. What is this graph all about? This graph is temperature versus time. Okay. This graph got temperature and also got time inside. So whenever you see, oh, the graph got temperature and time, you know already the graph must be heating curve or cooling curve. Then how you know these two, who is heating curve, who is cooling curve? Use common sense. Look at the staircase. This staircase go up. So when temperature go up, heating or cooling? Heating law, correct? When staircase go down, when temperature go down, heating or cooling? Cooling. Can you see that? Common sense. Just use common sense only, okay? Staircase go up means temperature go up. Why temperature go up? Heating. Staircase go down means temperature go down. Why temperature go down? Cooling. That's it. So from here, you know already it's heating or cooling curve. Example. Put your eyes on here, everyone. Put your eyes on here. You look at here, you know already, isn't it? Okay. The first one, what is it? Heating curve. Okay. Staircase go up. Second one, what is it? Cooling curve. Third one, what is it? Heating curve. Fourth one, what is this? Alien. What is alien? Tangga naik, lepas tu turun. Got up and down. Do we learn this? No. We only learn up or down. We never learn up and down. Okay, so this is nonsense. Confirm out already. Get it? So from the staircase, you know already, oh, this is heating curve or cooling curve. Okay, your heating curve and cooling curve maximum only got two staircases. Maximum ada dua tangga sahaja. Okay, how to know maximum two staircase? You go to see maximum two horizontal line. You see, example, everyone. Tangga, naik, flat, naik, flat, naik. 1 and 2 staircase. It is impossible here, one more. I'll tell you why in a short while. Okay, same thing, cooling curve. Down, flat, down, flat, down. Satu dan dua. So 2 staircases. Impossible, here got one more. So maximum only got 2 staircases. Why? Why only can have 2 staircases maximum? Why cannot be 3? Why cannot be 4? Simple. Okay, you all must know why we need to learn heating curve and cooling curve, not for fun. We learn heating curve and cooling curve because heating curve and cooling curve can help us to find this melting point, boiling point, condensation point, and freezing point. They can help us to find melting point, takat lebur, how much? Boiling point, takat didih, how much? Okay, condensation point, freezing point, how much? Okay, so when you heat, you will melt and boil. When you cool down a substance, you will condense and freeze. As simple as that. So why only 2 staircases maximum? Because you see, common sense, everyone, common sense. when you hit a substance, let's say I give you a solid, pepejal, solid. When you hit a solid, what happened first? Melting. So all the melting, boiling, condensation, and freezing only happen on the horizontal line. Okay, all the melting process, boiling process, condensation process, freezing process happen on this horizontal line. Okay, the flat line. So when you heat a substance, melt. After melt, heat again, boil. After boil, anything can happen. Nothing, ma. After boil, already become gas. You heat the gas, nothing will happen already. That's why only two tangga, two staircases. Same thing. When you cool down a substance, I give you a gas. Let's say I give you a gas. When you cool down a gas, what will happen first? Everyone let me know in the chat box. Kalau anda diberi gas, if you are given a gas, when you cool down a gas, what will happen first? What will happen when you cool down a gas? UBSR, condense. I ask you what will happen. You write liquid. Okay, guys, you don't understand the question. I ask you what will happen. So it's condensation. I didn't ask you what it become. So you have to be careful, isn't it? See the question, the way they ask the question. What will happen? Okay, condensation. Okay, I didn't ask you what it became or what it becomes. Then only liquid. Okay, cool down a gas, it will become liquid. The process is called condensation. So after condensation, you got liquid already. So you cool down the liquid more. Okay, then after liquid cool down, become freezing. So you see, after freezing, apa yang boleh berlaku lagi? Tak ada dah kan? After freezing, already solid. Solid, you cool down, still solid lah. Okay, no more changes. That's why no more. So everyone, let me know in the chat box. Do you understand why heating curve and cooling curve only got maximum 2 staircases? Do you understand now? Simple thing, must be 2 staircases, cannot be more than 2. All right. Now, when the question only got 1 staircase, how you know this staircase is what? You see, okay. Okay, so when you only have 1 staircase, how to know this staircase represent what process? Okay, listen and follow my thought process. I don't want you to copy the answer or whatever thing. I want you to learn how I think, the way how I think. This is more important. Guys, first of all, look at this question. Heating or cooling curve? Heating curve. Why? Temperature up, isn't it? So this is heating curve. So when you go for heating curve, ada dua kemungkinan kan? When you heat a substance, bila kamu panaskan sesuatu bahan, when you heat a substance, there are 2 possible things only. Maybe melting, maybe boiling, right? So how to know is melting or boiling? Many people say, sir, easy lah, melting. Wrong. Why? Depends on question. When you only have 1 staircase, this staircase may be melting, may be boiling. How to know? Okay, 2 staircase confirm already. Melting is here, boiling is here, confirm. 2 staircases is very easy one. 1 staircase is the problem. So how you know is melting or boiling? We which wash? Check temperature. No. Nigel, liquid to gas? No. Okay, shrimping, good. Look at the question. Read the question carefully. So if the question say, listen, Arya, listen to me, listen to me. This is a heating curve for solid W. So if they tell you, ini adalah heating curve for solid W, which means what? You start with solid. You are given solid. So when you're given solid, you hit the solid, what happened? Melting, isn't it? All right. But if the question say, this is a heating curve for liquid W, different story, isn't it? You are given liquid. So when you hit the liquid, then it will be boiling. So when you only got 1 tangga or 1 staircase, you have to be careful. Satu tangga mungkin adalah melting or boiling. So you all have to be very, very careful. Same thing. If you only got cooling curve, go down, only 1 staircase, satu tangga, maybe it's condensation, maybe it's freezing. How you know? Read the question. So if they say, this is a cooling curve for liquid W, then you know already. You are starting with liquid. Kalau liquid disejukkan, when you have a liquid, you cool down, you become solid. So this is freezing. If this is a cooling curve for gas W, you're starting with gas, you cool down. Gas cooling down, condensation. So when you only have one staircase, you need to read the question carefully so that you know that you are starting with what? Starting with solid or liquid or gas. Then only you know the process is melting, boiling, condensation, or freezing. Let me know in the chat box, can understand or not? So be careful with these small details, okay? Small details. Okay, I get a good question here. Shimping asks, for heating and cooling curve, would they ask about sublimation? No, won't. They won't ask about sublimation for heating and cooling curve. Yeah, that's it. All right, now, let's do a quick revision on this. Okay, you must know how to do the heating curve experiment. So how to do heating curve experiment, everyone, okay? So we don't do direct heating. So this is a substance that you want to melt. You don't heat directly. Why? When you heat directly, maybe the temperature is uneven. Maybe you see when you heat, this is the fire. Maybe the fire a little bit sengit to the left. So here will become very hot. Here not so hot. You don't want. You want the whole thing to be same temperature. So when you do heating, we don't do direct heating one. We always go for indirect heating. So how to do indirect heating? You go to take water first, take a basin. Inside can put water or oil. Okay, go to heat the water or oil. When the water or oil become hot, then only they go to heat the substance. When you do that, you can see they heat this substance from all directions. So this substance can be heat evenly. So if exam asks you, what is the function for water bath or oil bath? This, when you take a beaker, inside put water or oil, you call it water bath or oil bath. If the question asks you, what is the function for water bath or oil bath? So the function is this, okay? You want to ensure that you have uniform heating. You want to make sure the heating is steady, evenly, okay? Evenly, okay? Every place heat equally, okay? So, or you can write even heating also can, okay? This is very important, Okay, so when we need to change the water bath to become oil bath, sometimes we don't use water one, we use the oil. When? Simple. When the substance you want to heat, the temperature is more than 100. Example, I want to heat the substance to 170 degrees Celsius. Can I use water bath? Yes or no? Can I use water bath if I want to heat the substance to 170 degrees Celsius? No. Okay, now my question, everyone, I hope everyone respond to me in the chat box. Why? Why cannot? Kenapa tak boleh? Okay, very good. Water boil at 100. When you heat until 100, the water boil. When water boil, they become gas. When all the water become gas, this water dry already. The water dry, then you still didn't get 170 degrees Celsius. Cannot. So you cannot heat a substance to 170 when you use a water bath. So you change the water to oil because oil can tahan higher temperature. Oil can withstand higher temperature. You heat the oil until 200, the oil also doesn't boil yet. So that's why we change the water to oil bath. Sometimes they not even use oil bath. Sometimes they use sand bath. Same thing. Inside put the sand. Heat the sand. When the sand very hot, then the sand will heat the substance also can. So if the question asks, when you should replace the oil bath, sorry, when you should replace water bath with oil bath or sand bath, when you want to heat a substance to a temperature more than 100 degrees Celsius. When you want to heat a substance to a temperature more than 100 degrees Celsius, then you use oil bath or water bath. Finish. Okay, make sure you know this. Okay, one more thing before we do some question together. This is a super popular SPM question for your first term, for your midterm exam. Very likely this question will be tested in structure or essay. Very likely this question will be tested in your structure or essay. Why the temperature is constant during the melting process? Okay, why during the melting, during boiling, during condensation, during freezing, temperature never change? Example, you heat the water until 100. So the temperature will stop at 100, stop, never change, until all the water become gas. When no more water already, everything become gas, then only temperature changes. Okay, so during melting, during boiling, temperature never change. Why? Look at here. All the heat absorbed is used to overcome the kinetic energy between solid particle. No change in kinetic energy, no change in temperature. Okay, is it easy? Not hard, but trust me, a lot of students, they cannot do it for two reasons. Number one, some students cannot memorize this. Okay, some students, even they can memorize, they can copy bulat everything from this answer. They still don't understand what is happening. They still don't understand what is happening. So for me, I not really encourage you all to memorize, because why? If you memorize, maybe you can score very well in KBSM, the old syllabus. Maybe, yes, you can do very well, but not for KSSM. Because you all should know, okay, you all should know that when you come to KSSM, you are running on more and more KBUT, right? There are more KBUT critical thinking HOTS question, isn't it? So the question will twist and turn. They didn't ask the question so straightforward. So if you go to memorize, that's the problem. When the question change a bit, you cannot do already. You cannot do already. That's why a lot of students got phobia when they come to KBUT question, because the fundamental is terrible. A lot of students, majority of students, the fundamental is very bad because they only memorize. They just memorize, but they don't understand. So I don't want you to memorize this. I want you to imagine. Follow me, imagination. Okay, all right. So if you guys attended, like for example, Mr. Cole lesson just now, you can see what he did. He do a lot of visualization, right? Visualization like the mitosis, meiosis, the one like, okay, dating, holding the hand, you are part of me, I'm part of you, something like this, okay? All right. So when you can imagine what is going on, it will be a little bit easy. So I want you to, first of all, I want two things only, okay? Okay, let me ask a question first. Anyone struggle to answer this question all the while? Anyone? If you struggle to answer this question all the while, no matter you are form 4 or form 5, you type me. You struggle this question. Every time cannot answer one, you type me. I want to have a look. Okay. Quite a number, yeah, quite a number of students, quite a number of students having problem to you know, to answer this question. Yeah, no problem. Okay, so I'll help you on this. Okay, I'll help you on this. Okay, now I want you to imagine. So you only need two things. So I give me about 3 minutes. Let me explain this whole thing to you. First of all, you must know temperature and also kinetic energy. These two are adik-beradik. I want all of you to know temperature and kinetic energy, they are best buddies. They are best buddies. Temperature increase, kinetic energy increase. Temperature decrease, kinetic energy decrease. Temperature no change, kinetic energy no change. So you need to understand this concept first. Okay, why when you do melting and boiling, the temperature never change? Listen this. Okay, I want you all imagine this. Melting, what you do? This is solid, you want to become liquid, right? So you all can imagine this. Solid is something like this. Liquid is something like this, isn't it? All right. So how to change this to this? You want to break the force of attraction, because initially they join and sticking together. So imagine this, everyone. See, imagine this. Look at me. Look at the webcam. Look at this. Imagine initially they sticking together. This purple color, they are sticking together one. So during melting, you want to break. You want to break. So now they become liquid. So that is what we want to do. Okay. So when you want to break them, you all can imagine. You all can imagine they are something like this. Just imagine this is a solid. This is a solid. They're holding their hand together. Okay. First. So when they're holding their hand together, they are solid. So if you want to make them liquid, you need to make them break up like this. Okay. True now, because solid, everything sticking together, liquid, they are separated. So if you want them to break up, what happened? Okay, you need something to break them. So what happened? Heat. So when you do a heating curve, you heat the substance, you heat the substance. The heat is the knife. The heat is a knife that will come in to cut them apart, so to separate them. So when the heat cut here, what is this? This is called force of attraction. When they hold their hand together, it's called force of attraction. When the heat cut them, don't use the word cut, use the word overcome. Okay? Initially, they hold their hand. You use the heat to overcome the force of attraction. So now they are separated. So all the heat come here and break them. So does the heat go into the solid? No, the heat didn't go into the solid. Does the heat go into the solid? No, the heat not going into the solid. The heat go to break the bond. So when the heat didn't go into the solid, this solid, the energy got increased or not? No. Let's say I imagine I am the solid, I got 50 joule, the energy. So did I increase the energy? No, because the heat didn't come in. If the heat come in, I become 70 joule, for example. But no, now the heat is a knife come to cut. The heat didn't go in. So this fella still 50 joule. So when the energy didn't change, does temperature change? No, right? Because the temperature and kinetic energy are they or are they? So how you write in words? So you can write this. All the heat absorbed, the knife, is used to overcome the force of attraction between the solid particle. Solid and solid holding the hand, use the knife to cut them apart. So when you use the heat to cut them, the heat never go into the particle. So particle punya kinetic energy didn't change. So I didn't get more or less energy because the energy didn't come into me. The energy used to cut my hand. The energy didn't come into my body. So the kinetic energy no change. When kinetic energy no change, temperature no change. Why? Kinetic energy and temperature is ade berade. Simple as that. So I want to ask a simple question here. So just now I can see a few of you probably maybe struggle a bit here. Maybe I just name a few, not to offend any one of you. Like for example, maybe just now Astro, Dave, Janelle, Nigel, Agilent, Shivan. Do you understand a bit better now? No need to memorize, right? I didn't ask you to memorize the words. I asked you to imagine what happened. Solid holding their hand together, melting, need to cut their hand, need to separate them. To cut their hand, you need a knife. What is the knife? Heat. So you take the heat, cut their hand. So they are separated and become liquid. When the heat is used to cut their hand, does the heat go into their body? No. If the heat not going into the body, do they get more energy? No. So when the kinetic energy never change, temperature never change. As simple as that. Okay, so I get another question from Ko-E. Is the same for boiling process? Yes. Boiling process, everything is the same. Copy the whole thing, only change this one. Now in boiling, who is holding their hand? Liquid. Liquid and liquid holding the hand, break them, become gas. So if today they ask you why the temperature is constant during boiling process, all the answer exactly the same, only change the word here. Overcome the force of attraction between liquid particle. Only change one word. The rest is exactly the same. Okay, Cohen, did I answer your question? Ko-E, sorry, Ko-E. Darren, freezing later. Freezing later. We are doing heating curve. Freezing is cooling curve. We will discuss in a short while. Okay, Uzaiman, do we need to mention the type of the forces? If you know the force, then you mention, like if you know the name of the force is called van der Waals, metallic bond, then you mention. If you don't know, then no need. For chapter 2, normally no need. Chapter 2, you don't need to specify what is the name of the force when they're holding their hand together. Chapter 4, chapter 5, then yes. Chapter 4, chapter 5, you need to know, okay, when they hold their hand together, the force is called van der Waals force, metallic bond, whatever. Yeah. But for chapter 2, no need. Okay, simple as that. So hopefully everyone gets some rough idea from here. Not very, very hard. Okay, so no need to purposely memorize one. Okay, let's do some quick question together and we touch a little bit on cooling curve, then we go on. Okay, let's look at here. So this is SPM 2006 So which one is a correct diagram for heating curve? Melting point means heating curve. Okay. So the answer is donkey. Why? Why the answer cannot be A? This thermometer go to put in water for what? You want the thermometer to measure this substance that you want to melt. Thermometer you put here, what's the problem? Thermometer not touching the substance. Thermometer not touching. So you cannot measure the temperature. Wrong. Okay. Look at answer C. What's going wrong? Thermometer touching the solid. Very good. But now look at here. This is the solid that you want to heat, the blue color. But how much is immersed in water? Only here is in water. So which means what? Only this part will be heated. Don't want. You want to heat everything. You don't want to heat only here. Okay. So that's why the answer is donkey. You see, this is the solid that you want to melt. And then you put everything under the water. So when you put everything under the water, the whole thing here can be melted. So the best answer is donkey. Not hard, but just need to be very careful. Okay, a simple question actually. Okay, a very simple question. Next one. So they say this solid X is heated in a boiling tube and a temperature is recorded. Melting point is 78. Which one should be the graph? A, B, C, or D? Come, let's try this. Which one should be the heating curve for the substance X if the melting point is 78? The answer is C. Okay, why the answer cannot be A? Because if you got two staircases, the first one is melting, second one is boiling. So the 78 is boiling temperature, not melting. So that's why it's wrong. Okay. So this one staircase can be melting or boiling. So 78, that's it. Okay. So remember, two staircases, the first one is melting, the second one is boiling. Okay. All right. Last one. Okay. Okay. One more thing to touch here. One more thing. In the heating curve, you must know something like this. Let's say you started with a solid. You started with a solid. When you go to here, on the horizontal line, this is where the change of state is happening. Melting, boiling, condensation, freezing is happen on the horizontal line. Okay, so here you have to be careful. Here is where you start melting. When melting start, you will get solid and liquid already because some of the solid already melted. So you have solid and also some liquid. So here, solid, liquid, solid, liquid, solid, liquid, solid, liquid until here. This is, you see, this is a line. Start to melt, finish melting. So at here, the melting finish. So here, everything is liquid already. Understand? So same thing. Here, boiling. Here, you start boiling. When you start boiling, you have liquid gas, liquid gas, liquid gas, liquid gas, liquid gas, liquid gas. Until here. Here, you finish the boiling. Finish boiling. Here, everything become gas already. So you have to be very careful. So when you see this, on the horizontal part, you always have two states. One, you see, solid and liquid, liquid and gas. When you have the slanted, okay, this one, slanted part, you only have one state. Okay, so this one you have to be very careful. Okay. Okay. So let me see a question. Okay, S and L, if the question we have to ask solid and liquid, not solid plus liquid. It's okay one. You can write solid and liquid. You can write solid plus liquid. It doesn't matter one. It's okay one. It's just a way of writing. It doesn't matter. Okay. So now let's go for here. Okay, this is a little bit K-bar. This question a little bit K-bar. They ask you. Okay, this is a K-bar question. They ask, which of the following which of the following phases show the strongest force of attraction between naphthalene? Okay, how to analyze the question here, guys? Okay, so how to do the question here? You see two staircase. The first one is melting. Second one is boiling, isn't it? Okay, so when you go for this question, all right, so I can see the answer. Nigel says C, S to T, wrong, it's wrong. Okay, so when you see strongest force of attraction, what does it mean? Solid. Solid has a strongest force, right? You learn in PD3, solid, everything stick together, the force is very strong, followed by liquid, then only followed by gas. So where you get solid here, this is solid. Okay, why it's not here? This is where the melting is ongoing. When melting is ongoing, when melting is happening, you will have solid and liquid. But at this part, melting not started yet. When melting not started yet, everything is still solid. So here, everything is solid. Solid has a strong force of attraction. So P and Q here. So the answer is A. Okay, not very hard, but this question is a little bit K-but. The question not very straightforward. So if you make a mistake, it's okay. Most importantly, you know what's going wrong. Okay, and how to improve from there. Okay, so this one done already. Okay, last one. Let's do this one, and we go for a quick one on cooling curve. Okay, so this is a heating curve of solid acetic acid solid. So how to do it? Heating curve, one staircase, maybe melting, maybe boiling. So they say you're starting with solid. So when we start with a solid, this process must be a melting process, isn't it? You start with solid, you heat it, it must be melting. So they ask, which of the statement can be deduced from diagram number 8? Which one is correct? No heat is absorbed in the first 2 minutes. Wrong. Heating curve from beginning to end always absorb heat. Heating curve from beginning to end always absorb heat, because when you do heating curve, you do pemanasan. When you panaskan sesuatu, what happened? All the heat come in, absorb. So A is wrong. Acetic acid need 8 minutes to melt. No. Why? Melting starting here. Okay, start. Melting finish here. How long it take? This one is 2 minutes. This one is 6 minutes. 6 minus 2, 4 minutes only. Melting only need 4 minutes, not 8 minutes. Next one, acetic acid undergo physical change from 2nd to 6 minutes. Yeah, 2nd to 6 minutes here got physical change. What is the physical change? Melting. Melting is the physical change. So the answer is C. Simple as that. Okay. So one more question that I wanted to highlight is that a lot of students are very careless. Look at here. When the question asks, what is melting point? Students always write this. Melting point is a point where solid change to liquid. This is wrong. Okay. Melting point is not a point. Melting point is a constant temperature where solid change to liquid. Yeah. Melting point is a constant temperature when the solid change to the liquid. Simple as that. Okay. So melting point is not a point. So when you write this keyword wrongly, everything is wrong. When you change this point to become constant temperature, everything is correct. So some students will ask me, sir, if I don't write the word constant, I only write temperature, okay? Can or cannot, depends on examiner. Some of the examiner who are a bit lenient, a bit chin chai, they say, okay lah, never mind, close one eyes, give you correct lah. But if the examiner is a bit stricter, so they'll give you wrong. So better you write constant temperature. Yeah. Why is constant? Melting point didn't change one. True or not? Okay. Let's say today this substance melt at 45 degrees Celsius. Tomorrow also 45. The day after tomorrow also 45. The melting point never change one. Same thing goes to boiling point. Okay. So with that being said, so we have successfully do a quick revision on heating curve. Okay. Okay, Shrimping say, in the question, when you read the textbook, they might mention about pressure, right? Textbook got mentioned about pressure, but in exam, you don't need to write that. Okay, textbook might write this. Textbook might write, melting point is a constant temperature where solid change to liquid at specific pressure. Okay, your textbook might write these words, specific pressure. So now the question is this, do you need to write this? You like it. If you write this, no extra marks. If you don't write this, they're not deducting your marks. So it's okay. So this is optional. You write or don't write, also okay. No problem. Okay? So depends on you. Okay. Right. So guys, so we have done the quick revision on heating curve. Let me know in the chat box so far, everyone okay with heating curve so far? Just a quick revision. Remember, guys, I'm not teaching you heating curve. We're just doing revision only. So I just highlight those important things. Okay, now I want to touch a little bit on cooling curve. Then we're going to move on and learn something more in more details. Okay, right, let's look at here. Cooling curve. So cooling curve, I just go through super quickly only. Super quickly. Cooling curve, this is the diagram. There is a test tube. There is a test tube. Inside, you have something you want to cool down. Example, a liquid. Let's say I want to cool down this liquid to become solid. So when you do cooling curve, you must put a conical flask outside like this. I use a black color to draw. You must draw a conical flask outside like this. Or you need to put a beaker outside like this. Okay? Why? Why you want to put a conical flask or a beaker? Okay, guys, listen carefully. When you want to do heating and cooling curve, you want the heating and cooling happen evenly. Evenly means what? Nicely. You heat slow and steady. You cool down slow and steady. If you don't put these conical flasks, I remove, what happened? If there is a wind blowing, okay, ada tiupan angin, kalau ada angin. So if you have a wind blowing, the cooling process will happen very fast. Okay, the cooling process will happen very fast. That's why imagine this. If I go swimming pool, after swimming, after I left the swimming pool, I feel okay, not very cold. But all in sudden got wind, got angin. Okay, I feel super cold. Why? The wind will speed up the cooling. The wind will speed up the cooling. That's what you see. Sometimes when you have some food which is very hot, like satay, very hot, what we do? We blow, isn't it? We blow. Because when there is a wind, it will speed up the cooling process. That's it. So do you want to speed up the cooling process? Don't want. I want the cooling process to be slow and steady. So that's why what I do, I need to put a conical flask like this. So when the wind is coming, the wind blocked by the conical flask. So the wind won't kacau me. The wind won't cool down the process too fast. Okay, Angel, very good. Very good words there. Super cooling. When you cool down too fast, you will get super cooling. Okay, what is super cooling, everyone? Cooling curve by right look like this. By right look like this. But if let's say there is a wind, when the wind blowing, the cooling process happen too fast, your graph will become chacat. Your graph will become like this. Look at here. You see, cool down too fast. So here it would be like this. This is called super cooling. You don't want. So if the question asks you, why we need a conical flask or beaker in the cooling process, we want to ensure even cooling. You want the cooling process to be slow and steady. And then we want to prevent super cooling. Why there is a super cooling? Due to wind blowing. So that's it. So you want heat, you want the heating to be evenly. That's why you use water bath. You want the cooling to be evenly. That's why you use conical flask or beaker. As simple as that. Finish. Okay. So would they ask you to draw this graph for the super cooling? No, they won't. But even they ask you very easy, normal staircase, normal tangga, just draw a sharp corner like this. Can already. Yeah. But so far, SPM never asked, never asked for the past 28 years for the super cooling graph. Never asked. Okay. Next one. Okay, now this is something, this is what a student asked me just now. Oh, by the way, this is also same thing. Cooling curve. Let's say I cool down a liquid. Okay, so what happened when you cool down a liquid? This is freezing. So freezing, what happened? Here, everything before freezing, liquid law. Here, freezing starting, liquid plus solid. Liquid, solid, liquid, solid, liquid, solid, liquid, solid, liquid, solid, liquid, solid. Until here. Here, the freezing completed. So from here and here is all solid. So if you understand heating curve, very unlikely you will not understand cooling curve. Because normally like this one, normally I see the students, they either don't understand both. Heating curve cannot, cooling curve cannot. You seldom see a students that heating curve very good, cooling curve cannot. Normally not like that, normally, okay? Because they are related one. If you understand heating curve, it will help you a lot when you come to the cooling curve. Okay, so now I want to show you this. Now, why the temperature is constant during the freezing process? Why when we do freezing, the temperature constant, temperature never ever change? Why? Okay, same thing. This one we need to imagine also, because this question, same thing, a lot of students have found, memorize the whole answer. They can write the answer in exam, but they don't understand what they are writing. Okay, they can have found the answer, they can put this answer in the exam, they can score full mark, but they don't understand anything at all. Okay, if you are that kind of person for this question, maybe you type number 5 in the chat box. Got that? You see, a lot. Okay, quite a number lah. So many students, they know this. Okay, they can really write this answer in exam, but they don't understand what's happening. They really don't understand one. So that's why I want you all to imagine. So I want you all to imagine. Same thing. Let me show you a picture first. Okay, cooling curve. So now what I want to do, I want to do cooling. I want to do freezing. Freezing, I want to change liquid to solid. So liquid to solid, what happened? Everyone, put your eyes on here. This is a liquid. This is a liquid. So liquid to solid, they want to hold their hand, not separate, because liquid look like this. Liquid look like this. Solid look like this. So you want them to stick together. So stick together, you want them to hold their hand. So different from melting and boiling. Melting and boiling, you want to break them. You want to break their hand. But condensation and freezing, you want them to stick together. You want them to hold their hand. Okay? So remember this, I want them to hold their hand. Okay, first and foremost, in this, let's say initially I got 70 joule. That is the energy in my body. Initially, you got 70 joule. That is the energy in your body. Okay, when we do cooling, when you cool down, what happened? The heat will go outside. Okay, you will lose your energy. That's why you feel cold. If the heat go into your body, you feel hot. Okay, when you cool down, the heat is leaving your body. So when you do cooling process, so the heat go up. Let's say go up how many? 10 joule. Okay, let's say go up 10 joule. By right, if you lose energy, 70 joule should become 60 joule, right? 70 joule should become 60 joule. By right, when kinetic energy decreases, your temperature should decrease, right? By right. But the question say the temperature is constant. The temperature never change. Why? Put your eyes on here if you don't understand, because of this. Okay, yes, I throw some energy to the surrounding. This energy I throw to surrounding, you call it heat loss. You call it heat loss to surrounding. You throw the heat to surrounding. Okay, now, when I want to do freezing, I want these two liquid to hold their hand together. So you see, everyone look at here, hold their hand together. So when they hold their hand together, okay, zoom in. When they hold their hand, so they form the force of attraction. You see, when I break them, I am overcome the force of attraction. When I hold the hand, I am forming the force of attraction. So this forming, when you form the force of attraction, they will release the energy. They will give you some energy. You see, when I hold your hand, you can feel my energy. Okay, sometimes you feel safer. Imagine this, guys. Okay, let's say you are so panicked. Let's say now your father is holding your hand. You somehow feel safer. You feel safe when your father or anyone is holding your hand. Why? Why you feel safe? Because simple things, not chemistry related. When you hold people's hand, you feel energy. Okay, you feel the energy there. Okay, so when you hold their hand, you feel the energy. So holding hand will release energy. So coincidentally, this energy they release also same as energy they throw. They throw 10 joule. Now when they hold their hand, the energy they get is also 10 joule. So now look at here. Just now this fella lose 10 joule to the surrounding. Now you get back 10 joule when you're holding other people's hand. So I want all of you to understand this. Holding other people's hand will give energy to me. Okay, holding other people's hand, they will give energy to me. So this is called heat release during formation of force of attraction. Formation of force of attraction means holding hand. When they hold their hand, they will release the energy. So what happened? I throw 10 joule to the surrounding, but when I hold other people's hand, I get back 10 joule. How many energy I have? Still 70. Imagine this, everyone. I got 70 ringgit in my pocket. Now I throw 10 ringgit away. But at the same time, when I hold people's hand, when I hold the hand, these people give me 10 ringgit again. So I got 10 ringgit throw away, 10 ringgit get from holding hand, I still got 70 ringgit. So my kinetic energy didn't change at all. I didn't change kinetic energy. I still got 70 joule. So when kinetic energy never change, the temperature never change. That's it. Okay? As simple as that. So if you look at the answer, you see, does it make sense to you now? You see, the heat loss to surrounding, the 10 ringgit I throw just now, same as the heat release during the bond formation between liquid particle. So bond formation between liquid particle, if you don't want to say bond formation, you also can say formation of force of attraction. So what is this? Holding the hand. Holding the hand also give me same 10 ringgit. So 10 ringgit go out, 10 ringgit come in. So what happened? My money is the same. My kinetic energy no change. When kinetic energy no change, my temperature no change. Let me know in the chat box, is it a bit easy to write this statement now? You imagine, right? You don't memorize, you memorize the whole sentence, is not going to be very helpful one. Okay, slightly better, of course. Okay, I don't expect you listen to this, you'll fully understand immediately. No, it won't be that case. But I hope you feel better than before, even 10% before than when you first joined the class just now. It's also better already. So at least I want all of you, after these 2 hours, you learn something. You might learn a lot, you might learn little, doesn't matter. At least you learn something. You are not wasting your 2 hours time. That's what I want only. Yeah. Okay, so how to further improve? Do exercises. Okay, after understand the concept, do exercises. When you do first time, cannot, never mind. Okay, look at what is the mistake and improve from that. Do one more time. You don't, guys, you can redo the same question one, like for example, this question, if today you cannot do, never mind. You read, try to understand the whole concept. Then after that, you do the same question again. So if now you can do, you improve already. It's okay one. You can do the same question one. You don't need to keep on looking for new question one. Do the same question. Also okay one. Yeah. All right, finish. So we are all done with the cooling curve. Okay. So now let's look at here. Okay. Just a quick one here. All right. This is SPM 2009. This is a cooling curve for liquid Y. So quite easy. Cooling curve for liquid. So liquid cool down. This is freezing. So they say, this question say what? At T1, the y-axis is solid. T1, you are solid. Yes or no? Guys, let me know in the chat box. Yes or no? Are you solid? Are you solid? No, Why? This is where the freezing first started. When freezing first started, you have liquid, but some liquid already become solid. Should have two things. So they say only solid. No lah. Freezing point is 70. Freezing happened at here, 70. Okay, the answer is B. Simple as that. So this question I don't want to discuss. It's quite easy. So I want to show you the next one. Quick one. All right, here. So there are total 5 scientists which contributed to the development of atom. Okay, like today we know atom inside got proton, neutron, electron, all these concepts, they are actually the contribution for 5 scientists. So how to memorize? You can memorize like this. Don't throw rubbish. Don't throw rubbish below carpet. Don't throw rubbish below carpet. We want to save the earth. We want to protect the mother nature. Okay, you can create a sentence like this. Okay, so look at the first letter, D, T, R, B, C. Look at the first letter, S, E, P, M, and N. Okay, so what is it? So D is, okay, on the left hand side, this is the scientist. So the scientist D is called Dalton. The scientist T is called Thomson. The scientist R is called Rutherford. The scientist B is called Bohr. The scientist C is called Chadwick. Okay, some student will ask, sir, do we need to know their full name? Like this fellow called John Dalton, J.J. Thomson, Ernest Rutherford. Do we need to know the full name? No need. You just need to know part of their name will do. So what does Dalton say? Dalton say atom is a S. S means sphere. Atom is a ball. So J.J. Thomson found E. E means electron. He found electron inside the ball. So Rutherford found P. P is proton. He found proton inside the ball. And the proton is in the middle part called nucleus. In the middle called nucleus. So the next one called Bohr. Bohr discovered M. M means moving. Electron is moving. And they not simply move. Electron move in a shell. Shell means orbits. Like see, imagine this. This is the orbits. So electron is moving in the orbits. So you can imagine electron like the moon is moving in the orbits. Okay, they move in the orbits. So this is what Bohr say. Last one, Chadwick say, Chadwick found N. N is neutron. So that is what you need to know. Okay. So if you cannot memorize this, a simple, no-brainer, easy method is copy. Take a piece of paper, copy the name of this, don't throw rubbish, save earth, protect Mother Nature, all these things, copied it. Every day, copy one time. No, I didn't ask you to copy 20 times in a day. I didn't ask you to copy 100 times, okay? Copy 1 times in a day. And don't say, sir, I got no time. Bro, 5 minutes. 5 minutes only. Okay. Sometimes I feel very annoying when I heard students say no time. Okay. You got 24 hours, I got 24 hours. Last time when I saw students, what happened? Sir, I got no time to study this, no time to study that. I got no time to do this, no time to do that. But this fella can spend 2 to 3 hours to watch Instagram and TikTok every single day. Got time for entertainment, but no time for this. Only 5 minutes, also don't have. Yeah. So if you can spend 5 minutes to copy, just copy the name, all this thing in 2 weeks time, confirm you were able to memorize. Okay. I say confirm. Okay. So far for the last 18 years I'm teaching, never fail. I never have a students who try this method, the copy method and cannot memorize one. Those who cannot memorize for one simple reason only, they copy for 1 day or 2 days, they gave up, they stop. That's it. If you really copy for 2 weeks, confirm can memorize, really. So if you are a person who are very weak in memorizing, you do this. Because sometimes a student always asks me, sir, chapter 3 got those ions. How to memorize? Like what I say, copy. Take a piece of paper, copy the name of the ion, copy the formula and the charge of the ion. Copy 1 time in a day. Copy for 2 weeks. Confirm can remember. Seriously. Okay, so if all the while you cannot memorize, why not give yourself the last chance and try this method? Okay, if after you try 2 weeks, you still cannot remember, you come back to me. You come back to me, seriously. Okay, very important. Okay, so now from here, you know, for same thing. Okay, isotope also do the same thing. Copy the name of the isotope, carbon 14. Okay, used to check the age of fossil and artifacts. Cobalt 60, treat cancer, kill the bacteria. Same thing. Yeah, just copy only. Just copy. All right. It won't take too much of a time. Some people say, sir, I have so many things to memorize. You can arrange your time. For example, these 2 weeks, you memorize the scientists first. Another 2 more weeks, you memorize the isotopes. Another 2 more weeks, you go to memorize the ion. It's okay. I didn't ask you to do everything at the same time because I don't want you to give yourself so much stress. You need to manage your time. It's okay, okay? Because if you are Form 4, you only take your SPM in another 1.5 years, okay? If even today you are Form 5, you only take SPM 9 months from now. You have the time. You have the time. As long as you make good use of the time, you can do it. Yeah, you can do it. Yeah, all right. Now, okay, just now when I say particle, I say Joshua, not confirmed yet, January, not confirmed yet. Okay, not confirmed yet. Yeah, there's a rumors lah, but not confirmed. All right. So subatomic particle, what is subatomic particle? Something inside the atom. So when you see subatomic particle, they are talking about proton, neutron, and electron. So many people always mess up particle and subatomic particle. Particle means atom, molecule, and ion. Subatomic particle means something inside the atom, which is proton, neutron, and electron. Simple as that. Yeah. So here we do a very quick one here. Who discovered neutron? Can follow the method we learned just now. Chadwick. Yeah, Chadwick discovered neutron. Now this question is interesting. This is a good question. I want you all try to do this question, and then we will discuss. Come on, let's try this. Let's try this. This is SPM 2018. Try to do this question and let me know the answer in the chat box. A, B, C, or D. Let's try this. I want to see probably 5 to 6 answers at least. Then only we discuss. Come on, let's try. Let's try. Okay, I can see many of you write A, right? Okay, congratulations. You're wrong. You're wrong. A is wrong. Okay, A is wrong. Okay, the answer is D. Okay, the answer is D. Why? Why? When this question came out, more than half of the students get it wrong. Listen carefully. More than half of the students get it wrong because they see the word electron move. They're so happy. Oh, move. Oh, move. Mr. Martin say move is nails ball. Ball. No. Just now I say what? Ball say that. Okay, just now. Ball. I think they don't know erase already. Ball say what? Electron move in the shell. Electron move in the orbits, like the moon. Remember, I said the moon? Electron move like a moon, move in orbits. They not move here and there. They move in their own orbits. Do you see the orbits here? No, this is not orbits. The orbits should look like this. The orbits they can draw like this, or they can draw like this. Okay, so this is what? Look at it, the orbit. Look at love shape. No way the orbits is love shape, right? Cannot. So this is not ball. So then what is the next closest one? Nucleus got proton. Who found proton? Rutherford. Can you see how tricky is this question? And you all can see the statistic yourself. How many of you answer A just now? You can see in the chat box. You all can see. So you see they purposely put ball as the first answer, because when you see ball, you thought electron is moving and you are so excited, you will circle the answer already, but it's wrong. Okay, so everyone let me know in the chat box, do you all understand why the answer is not ball? Why the answer is not ball? Because ball not only say electron is moving, but electron move in the shell. Okay, they not simply move here and there, they move in the shell. So this is how they mix a little bit K-bar concept in the real paper. Okay, next one. Okay, I want to talk a little bit on this. Okay, standard representation. What is standard representation? Standard representation is a way for them to represent a chemical substance. How they represent a chemical substance in chemistry. So like this, you will see a big symbol here, and you will see 2 numbers on top and bottom. On the top is a big number, at the bottom is a small number. Cannot terbalik. Cannot write small number on top, big number at the bottom. Some people say, sir, when I Google, I saw the small number on top, big number under at the bottom. Yes, okay, that is for other country one. Say some country they terbalik, they put the small number on top, big number at the bottom. But for Malaysia, okay, we are using big number on top, small number at the bottom. So please be very careful. This big thing is called a symbol. And then this big number called nucleon number. Nucleon number also can call mass number. This small number is called proton number. Proton number also can call atomic number. So many students, they know what is nucleon number. But when the question say mass number, they confuse already. They don't know what it is. It's the same. Many students know what is proton number. When all in sudden the question say atomic number, they cannot already. In fact, they are the same thing. So you have to be careful. And in your Form 4 midterm exam, there will be a question. They will definitely have one question to ask you on what is the definition of proton number or nucleon number. They will ask that. So if they ask you what is proton number, many students will write this. Proton number is number of proton, full stop. 0, no marks. So proton number should be number of proton in the nucleus of an atom. You need to write this. Why? This is atom. Atom in the middle got nucleus. Nucleus inside got proton and neutron. So if you know inside here got how many proton, that is proton number. So proton number is the number of proton in the nucleus of an atom. Everything need to be written. So if you have something missing, they will deduct your marks. Some examiner who are super strict, any one word missing, give you directly 0. Okay, so please be careful. Same thing. If the question asks you, what is nucleon number? What is nucleon number? You cannot say nucleon number is the total number of proton and neutron, full stop. Cannot. Same thing. You must tell people, this proton and neutron, where are them? In the nucleus. This nucleus belongs to who? Of an atom. So nucleon number is the total number of proton and neutron in the nucleus of an atom. So please, please, please be careful. Many students, they write the answer, they don't get the marks they deserve, they lose the mark, and they not even know why. They not even know why they lose the mark because of this. They maybe forget to write the word nucleus, maybe they forgot to put the word atom. So please don't be forgetful. I always tell this to my students, you forget to write the points, the examiner will forget to give you the marks. Fair enough. Yeah, fair enough. So don't be forgetful. Please be very, very careful with this. So these are some answering techniques that you all need to be alert of. Okay. So that's why I say, today we do revision, and we also talk about common mistakes of students and also some answering techniques. Okay, when they give you this thing, when they give you this standard representation, you always can use this standard representation to find 3 important information. You always can get 3 things from this standard representation. Example, I give you this. Okay, I give you this. Na, 23 and 11. I give you this standard representation. You always can give me 3 information. First one, proton. Second one, neutron. Last one, electron. So this is super easy. How to get proton? Proton always copy the small number, which is 11. Neutron always take the big number minus the small number. Very easy. 23 minus 11, 12. Electron, you all have to be super duper careful. Electron, you all have to be super duper careful. Okay, how to get the electron? You have to check whether this substance got charge or not. This substance got charge or not. If this substance don't have charge, okay, if the substance is neutral, don't have charge, the number of electrons same as number of proton. Okay, example, this one got charge or not? No charge. So no charge, the electron same as proton, which is 11. Okay, that's it. Okay, why? Why the electron and proton must be the same? Look at here. Every one proton, the charge is positive 1. Every one electron, the charge is negative 1. If you have 11 proton, the charge is positive 11. If you have 11 electron, the charge is negative 11. Mathematics, positive 11, negative 11 become 0. That's why they are neutral. Okay, so when the substance is neutral, the number of proton and electron must be the same. Okay, if the substance got charged, example, Na plus, Na minus, Na2 minus, if you got charged, how to find the electron? If you have charge, you just need to take the proton number that you have minus the charge. Take the proton number minus the charge. Okay, what do I mean? Look at here. Okay, let's say this fella, O2 minus 16 and 8. Let's do together. Okay, proton, how many? Take the smaller number, 8. Neutron, how to do? Big minus small number, 8. Okay, electron, be careful, be careful, be careful. So please be careful. Electron, you have to check whether it got charged or not. This one got charged. When electron got charged, the electron not the same as proton. So how to do? Electron is proton minus the charge. So proton is how many? 8. Minus, what is the charge? -2. -2. So 8 minus -2, 10. As simple as that. Let me know in the chat box, are you okay with this? Okay, if you don't want to do this, you also can use another common sense method to do. Okay, what is common sense? You see, in your chemical substance, you have proton, neutron, and electron. Who got charged? Proton and electron. Okay, so neutron don't have charge. Okay, neutron don't have charge. Okay, shrimping, the Na negative one, I just simply give example only. Don't be so serious. Okay, I just simply give example only. Na should be +1, just example only. Yeah, just example. Yeah, all right. So now proton and electron got charge. So you also can do this. You see, all right. Proton how many, electron how many, and the charge how many. You also, if you don't want to do this method, proton minus charge, I teach you another method. Okay, I teach you another method. Yeah, all right. So proton how many? 8. What is the charge of proton? Positive. Electron how many? Don't know, just now don't know. Don't look at the answer yet. Don't know. Electron, what is the charge? Negative. So after they add together, what is the final charge here? 2 minus. So can we do mathematics? Positive 8 minus something will get -2. So positive 8 minus 10, you will get -2. So their total 10 electron. Also can. Yeah, you want to use this method? Also can. No problem. Yeah. So I want to show you one K-but question. I want to show you one K-but question. Okay, before we finish off with the remaining part. Okay, one K-but question here. Okay, here. Okay, so now this one. Okay, this is a K-but question. Okay, here. Let's look at this one. The K-but question. This is SPM 2007. SPM 2007 K-but question. So they say, what is the nucleon number of element J? Okay, how to do it? First of all, when the question one nucleon number, what you need? Nucleon is proton plus neutron, right? Proton plus neutron. Do we know how many proton? No, the question didn't tell us how many proton at all. I don't know. Do they tell us how many neutron? Yes, the question say atom J has 12 neutron. So you have 12 neutron here. So now we need to find the proton number, how much? So how to find the proton number? So there are two methods. You can use the method I teach you just now. There are two methods. First method, the charge is 3 plus. So electron, how many? 1, 2, add together 10. So you have 10 electron. So you can use the method I say just now. Electron equal to proton minus charge, right? Electron equal to proton minus charge. Okay? So electron got how many? You can count yourself. Total 10. Proton, how many? Don't know. Minus, the charge is positive 3. Positive 3. So 10 equal to P minus 3. P equal to 13. So from here, I know already proton is 13. If you don't want to do this method, also can. Another method you can use is something I say just now. Proton and electron, they got charge. Proton, the charge is positive. I don't know how many proton I have. Electron, the charge is negative. Inside here got total 10 electron. So when they add together, what is the final charge? 3 plus. So mathematics, something minus 10 become plus 3. The something must be 13, isn't it? So I got 13 proton. So I take 13 proton, go to add 12 neutron. My nucleon number is 25. So this is a very, very good K-but question. They didn't ask the question so straightforward. They didn't ask the question so straightforward. They slightly changed a question a little bit. But if you understand the concept, it's not too hard. It's not too hard. Okay? So now I want to cover, okay, we are almost done with today's session. So give me another 5 minutes, okay? Give me another 5 minutes. Let me touch the last part. Let me touch the last part, okay? So electron arrangement, this is quite easy. 281, 2881, those things. So I only want to highlight two important things. many students always having problem to differentiate electron arrangement and atomic structure. Okay, what do I mean? You see, the question gives you this, ZEC 19 and 9. The question asks you to draw electron arrangement, and then the question can also ask you to draw atomic structure. There are a lot of students cannot differentiate. They don't know who is atomic arrangement, who is atomic structure, and who is electron arrangement. So how to do it? Okay, first and foremost, follow this. So how to know the electron arrangement? You must know how many electrons you have. So this fella is neutral. When you are neutral, the electron same as proton. So you have 9 electrons, isn't it? So the arrangement is 2.7. I hope everyone know it. So 2.7, how to draw? Draw 2 circles. First circle got 2 electrons. Second circle got 7 electrons. Okay, when I draw this picture, I won't get full mark. Can anyone point out my mistake? Can anyone point out my mistake? Why I don't get full mark, even I draw this? Okay, very good. Nucleus. So all of you remember, you need to draw nucleus. So you draw another one more circle, but don't put any electron on the circle. That will be nucleus already. Some school teach you nucleus must shaded like this, and then give arrow called nucleus. Not necessary. Not necessary. If you don't want to like shade the whole thing, just draw a circle also can already. No problem. Okay. So simple as that. Okay, what is atomic structure? So if you want to draw atomic structure, remember inside the atom, you not only have electron, you also have proton and neutron. So if the question asks you to draw atomic structure, in the middle of nucleus, you must write how many proton and neutron. So proton, how many? We know. Proton take the smaller number, 9. Neutron, big minus small number, 10. So you have 9 proton and 10 neutron. So everyone, do you know the differences between atomic structure and electron arrangement by now? You have to be careful, because so far, from my experience, many students always make some mistakes here. Question asked for electron arrangement, this fella go to draw atomic structure. And same thing goes the other way around. Question asked for atomic structure, and this guy go to draw electron arrangement. So you need to really understand the difference. Electron arrangement, only one electron. Atomic structure, atom got electron and proton and neutron. So you have to be very careful with it. Okay, so I'll teach you the last thing for today. The last thing for today is isotope. Okay, so just now got a student ask me how to memorize the isotope. Like what I said, take a piece of paper, copy. So these are some important isotopes you need to know. Carbon-14, go to find the age of fossil and artifacts. Example, you found the bone of dinosaur. You want to know this dinosaur used to be alive how many years ago? Use carbon-14. Cobalt-60 can use to kill bacteria and kill cancer. Sodium-24 can detect underground pipe leakage. So if underground got pipe leakage, you can use a special machine. The machine got sodium-24. They will put some signal. If got leakage, got some bocho, the signal is different. If no bocho, the signal is different. So that is sodium-24. Okay. So iodine-131 is used to detect thyroid disease. So if this person got thyroid problem, do you know where is thyroid? Thyroid is here. Okay. Your right hand touch here, the left hand side of your neck over here. This is thyroid. Thyroid is used to control your body temperature. Okay, like when you go into a swimming pool, it's very cold initially, but after a while, you don't feel so cool already. Why? The thyroid will adjust your temperature. Okay, when it's very hot, the thyroid will make you sweat so that you feel not so hot. Yeah, this is thyroid. Yeah, so if the thyroid got problem, you can use iodine-131. Uranium-235 is used to produce energy in nuclear power plant. So we can use nuclear energy to produce power. So that is uranium-235. Last one, phosphorus-32. Phosphorus-32 is used to study the plant metabolism. So you want to know this plant how it works, like how the plant absorb the water, how the plant absorb the fertilizer. You can put some phosphorus 32. So like what I say, how to memorize? Take a piece of paper, copy the name of the isotopes, copy the function of the isotope. Give yourself 2 weeks time, and that's it. Okay, so I want to ask one last thing here for today. Anyone have problem to find this? Like for example, today if they give you isotopes like this, today if they give you isotopes and then percentage, and then they ask you to find the mass, anyone don't know how to calculate this kind of question? Anyone? If you don't know how to calculate this kind of question, like me, so okay, this will be the last thing I'll teach if you don't understand. Anyone don't understand? If let's say they give you the isotope, like for example, the isotope they give you, this is isotope X, 35 and 17, isotope X, 37 and 17. This isotope X got 75%. This isotope X got 25%. How to find the mass of them? Okay, so there are some students don't know how to do it. So I'll teach you, very simple only. When they give you different isotopes, okay, and they ask you to find the mass, very easy only. You just need to take the nucleon number of the first isotope multiplied with the percent. Go to add the nucleon number of the second isotope times the percent. Go to add the nucleon number of the third isotope and the percent. So you see lah, how many isotopes they give you. Normally SPM maximum 3 isotope. Normally maximum 3 isotope. So in the end, divide by 100%. Simple as that. Okay, example. Let me use these two examples and we finish with today's lesson. Okay, so how to know how to calculate? You see, nucleon number is what? The big number. So this one, the big number is what? 35. So how many percent? 75. 35 times 75. So plus, so this is another isotope. What is the big number? 37. What is the percent? 25. Do you still have other isotope? No more. So when no more isotope, divide by 100. That's it. So if you calculate, you will get 35.5. That's it. Okay, one more example here. There are total 3 isotopes of magnesium. Okay, this question a bit chachat. They didn't give you the symbol of the isotope, so they should give you lah. Magnesium can be magnesium 24, magnesium 25, and magnesium 26. So they didn't put in. So it's a bit chachat. So they tell you magnesium 24 is 79%, is here. Magnesium 25 is 10%. Magnesium 26 is 11%. So they ask you to find the mass of magnesium. So this one quite simple. So remember, you have 3 isotopes. You do 3 times. First one, take the big number of the isotope number 1 times the percent. Add weight, the big number of second isotope times with the percent. Add weight, the big number of the third isotope and the percent. And then everything divide. So when no more isotope ready, stop. Divide by how many? 100%. So if you do the calculation, you will get the answer 24.32. This is very, very simple only. Understand? Just take the isotope, the big number, times with the percent, add weight, another isotope, the big number, times with the percent. You add until no more isotope, divide by 100. End of story. Finish. Okay? So guys, let me know in the chat box. Are you okay? And do you understand this calculation? It's actually very easy, right? Or not? Okay. So you see, actually, we don't need to memorize so many things, right? Okay. Don't need to memorize so many things. Okay. So before we end up with today's session, so let's do a very quick closing remarks. Okay. So the time is very limited. Seriously, guys, the time is very, very limited. So I only managed to go through chapter 2 quickly. Yeah. And I didn't touch anything about chapter 3 at all. Okay. So what I will do is this. Okay. What I'll do is this. Okay. If you really weak in chapter 3, okay, one of the things you can do is, because some of you might know I have a YouTube channel, some of you don't know. Okay, so for those who don't know I have a YouTube channel, you can go to YouTube and search for my name. Yeah, just search for my name will do. Then in the YouTube channel, so I do have a playlist for chapter 3, chapter 4, and chapter 5. Yeah, so if you're struggling for your mole calculation, especially chapter 3, go to watch the video. There are total 5 videos there. There are total 5 videos. spare your time. You don't need to watch all of them in one day. Okay, take your own time, adjust your own schedule and watch it. After you watch the 5 videos, I can't guarantee you'll be 100% understand the whole calculation of mole, but you will at least understand 70% of it, at least 70%. Yeah. So if you really struggle in mole calculation, this is the help I can offer for you. Okay, you can really do this. Okay, it will help you a lot. Why? Mole calculation is so important. They will ask the mole calculation in any chapter they want. Yeah, they can ask the mole calculation not only for Form 4 chapter 3. They can ask in any chapter in the Form 4, any chapter of the Form 5. So the mole calculation is very important. Yeah. So Huzaiman, if you need help with chapter 7 and chapter 6 and chapter 7, we have an e-learning program. Actually, if you want, you can join. Okay, which will give you a very good help lah. Okay, this question answer, I will contact the host WeGrow, and then they will send to you probably in a day or two. Yeah, they will send all these answers, okay, in a day or two. Yeah. All right, so I think that's all for, yeah, they will send, I think they'll send by email. Yeah, I think they'll send by email. So they will inform you all again. Yeah. So I think that's all for today. So thank you so much for your time, and thank you so much to stay back until now. All right. So have a good rest and hope to see you guys soon again. Bye-bye.